Hello everyone, we are from Meow Rangers. So today we are going to present to you guys about applied maximum and minimum problems. Zati and Aini are my team members and they will explain to you guys about how to find maximum and minimum value. Before we get to the question, what do you guys think about applied maximum and minimum problems? So, the process of finding maximum and minimum values is called optimization. We are trying to do things like maximize the profit in company, or minimize the cost, or find the least amount of material to make a particular object. These are few steps to solve the maximum and minimum problems. First, you must find the derivative of the function. Second, set the derivative equal to 0 and find the values of the variables. And third, do the second derivative test. So, let's go to the question.
The question is, the diagram below shows a piece of 80 cm by 80 cm cardboard. These 4 square corners are cut out so that the sides can be folded up to form a box. A. Show that the volume of the box is given by this volume, which means it wants us to find the answer that proves this volume is true. B. Find the value of x, which will yield a maximum volume. So I summarize the question. It wants us to find the value of x for us to get a maximum volume. C. Hence, determine the maximum volume of the box correct to 2 decimal places. When we get the answer of the box, which is the maximum volume, then we have to correct it to 2 decimal places.
So for question A, we need to show how do we get the volume that has been given. As we know, the volume of a box is length times width times height. How do we get the values? By referring to diagram that has been given. So this is what I got from the diagram, which is length equal to 80 minus 2x. Why 2x? Because we already cut out the square corners so that the side can be folded up to form a box like this. And then the width is also the same because this is 80 by 80 centimeter cardboard. And the height is x, like this. We already cut out the square corners, so when we fold it up, it will become x. So, all we need to do is, we just substitute the values that we got into the formula. And we expand, and we will get the same answer. Move on to question B. We need to find the value of x which will yield a maximum volume. So step 1, we need to find the first derivative of the equation that we've got earlier. So we are applying power rule to the equation. In order to apply the power rule, we just need to follow the formula that we learned in the class. This is our equation, and we just follow the formula like this. 3 multiply with 4x to the power of 3 minus 1, and we do the same thing to the rest of it, and we will get 12x squared minus 640x plus 6,400. So that's how we got the first derivative. Step 2, we need to let dv over dx equal to 0, like this. And then we do a factorization, which is we will get x equal to 40 and x equal to 40 over 3. Step 3, we need to do the second derivative test. It is to test value of x either maximum or minimum. So this is our first derivative. In order to get the second derivative, we need to apply power rule to the first derivative, and we will get 24x minus 640. And then we need to test both x values that we got earlier into the second derivative. For the x equal to 40, we will get 320. 320 is bigger than 0, which will yield a minimum volume. And then for x equal to 40 over 3, we will get negative 320. Negative 320 is lesser than 0, which will yield a maximum volume. So the answer for question B is x equal to 40 over 3 centimeter. So for the last question, we need to determine the maximum volume of the box correct to 2 decimal places. So this is our volume of the box, and this is our x value, which will yield a maximum volume. We just need to substitute the x max into the equation. So we will get 37,925.93 centimeter cube. So this is our maximum volume of the box, and we need to correct to 2 decimal places.
So, we can conclude that problems described in words are usually more difficult to solve because we need to understand first and translate the problem into a mathematical problem. Unfortunately, those skills only seem to come with practice.
With practice, you will start to recognize patterns for understanding, translating, and solving these problems, and you will develop the skills you need.
So, read carefully, draw pictures, think hard, and do the best you can.
And finally, these are all the materials that we refer to complete our task. So, that's all from us. We hope you guys enjoyed this video. Thank you.